Okay, 4.9. This is a pretty easy one. Okay. These are perfect squares, okay, the numbers in the square roots, because you can write it as a number times itself. Square root of 4 is 2, 3 is 9, 16, and then it goes all the way up to 225. Now, 256 is 16, and then so forth, okay? So we'll be using that list. Now, I want to start off this by, it says find the product, okay? So you've got 2x plus 3 multiplied by 2x minus 3. So I expect this is going to be a trinomial, only it's not going to end up as such, because you're going to distribute 2x to 2x and then 2x to negative 3. Then 3 to 2x and 3 to negative 3. So you get x to the second, 2 times 2 is 4. You got x, negative 6, and then x with positive 6, and then negative 9. So you got your A, B, B, and C. So when I line up my terms here, for x second I have 4, but for the x's, negative 6 plus 6 is 0. So when it's 0, you cross out that term, okay? And then you end up with negative 9. Now, what I have come up with is a difference. By the way, you'd write that as 4x squared minus 9. And this right here is known as a difference because you have a minus sign, of perfect squares, okay? Otherwise known as DOPS, DOPS, okay? And you notice how this is an A and the B has been dropped out and it's C. The only way the B is dropped out is if you have a difference of perfect squares, so there'll be no B term, okay? These are very easy to factor, okay? So here's my problems. Factor the expression. Okay, but this is much easier than factoring the ABC, much less time consuming. Okay, now you're factoring, you're not solving. Now, you have an implied 1 there, that's your A, and then you don't have a B, you have a C. So like before I do GCF, 1 and 25 would just be 1. I can't do X because again I have C. Anytime I have C, I can't do X because C is a constant. And A is positive, so GCF is positive, so we're not doing the GCF, okay? Now, so with an AC, just like ABC, I need an AB, I do the GCF first. That's always the first step in any factoring. But now with an AC, you make a box, but you don't, it's not very big. You're just rewriting the expression as a difference of perfect squares. Now here's how you do that. You make 2 parentheses. First you make sure you have a minus. One's plus, one's minus. And then you're going to forget the 1. X to the second, you can write that as x times x, and then 25 is a perfect square because that's 5. That would be 5 times 5, okay? So this is your answer, x plus 5 times x minus 5. So it'd be x squared, negative 5x, positive 5x, cancels the b out, and then negative 25. Okay, next one, we have negative 4x to the second plus 100. So again, that's an A and a C. So AC, I identify the GCF first, then I see if I have a difference of perfect squares. Okay, so if you look up 4 and 100, they're both in the 4th row, okay? And you need to attach a negative onto that because your A is negative, your GCF is negative, so you're going to go ahead and do the GCF. Okay. So negative 4 gets factored out, and then I divide by negative 4. And I end up with x to the second, 1x to the second. You can drop the 1 later on, minus 25. If it's negative, you write it as minus. Don't put plus negative. You need to write those as minuses. Okay, so I place a negative 4 out front here. Okay, now for the parentheses, we can drop the 1. That's x times x, and I have the minus. That's 5 times 5, so I'm good to go. X, 5, 5. So negative 4 times x plus 5 times x minus 5, and that's been factored. Okay. Okay, next one, we have 9x to the second minus 4. So an AC quadratic, first we see if we have a GCF. Then we see if we can do a difference of perfect squares. Okay. Question mark. Okay. So GCF 9, 4 is 1, and then the x, no, anytime I have C, and A is positive, so it'll just be 1, so we're not going to worry about the GCF. Now DOPS, first off I make sure I have a minus, it has to be a minus. If it's a plus, this can't be done, okay? So 9 is 3 times, 9x squared would be 3x times 3x, okay? Because 9 is on this list, 3, okay? And with the x to the second, we rewrite that as x times x. And 4 is 2 times 2. So I go 3x2, 3x2, and that's your answer. 3x plus 2 times 3x minus 2. Again, the minus has to be there. That's 2 times 2. This would be 3 times 3, and then x to the second is x times x. Okay. Okay, next one. 144x to the second minus 16. Okay, an AC quadratic is factored if your directions are to factor. Okay. First you identify your GCF, then you're going to set a box down here. Okay. But you're going to write DOPS question mark. So if you look at 16th row, the actual 16 row, 144 is there. Okay, so 16 is your GCF. So you wouldn't put x with it, and it would be positive because A is positive. Anytime A is positive, the GCF is positive. So we're going to go ahead and do the GCF. So I put 16 in there, then I go up and divide by 16. Drop your minus. 16 divided by 16 is 1. 144 divided by 16 is 9, and the x to the second is still on the 9. Now you're checking here, okay? You're not looking there. That's an AC, not an AB. I don't know why I put that there. AC. B is not present, so it's got to be. Okay, now you're looking here. You're going to place 16 there before the parentheses. Don't forget about that. So anytime you do a GCF, put it there. Okay, so I have my minus. 1 times 1. 9's here, it's 3 times 3. And then the x to the second means I attach a factor of x to each of those 3's. So it'd be 3x1, 3x1, and that's my answer. 3x plus 1, 3x minus 1. Okay. Let's keep it going. Okay, next one, we have x to the, this one's an odd one, x to the second plus 49. So I put the implied 1 for my A and then a C. I don't have B. So the way an AC is factored is first identifying the possible GCF, then going down here. I'm going to leave room for my box if I need it. And then seeing if I have a DOPS. Okay. Plus minus. One's plus, one's minus. Has to be. Okay, 1 and 49, well, just be 1. Can't do x, and A is positive, so I guess it's just 1, so it's not worth doing when the GCF's just 1. And if GCF's anything other than a positive 1, we're doing it, but it's not. Now, you have a little problem here, that's a plus, okay? You can't factor that as a DOPS, and it has to be a minus, okay? So what you write is the word prime, meaning that cannot be factored. Again, you have to have the minus. You can't, don't put 1x, 1x, 7, 7. If the minus ain't there, it's not a DOPS, it's prime, different. Okay, next one, negative 5x to the second plus 125. Okay, so you got an AC quadratic. Okay, first I do figure out the GCF, then I go down here and ask myself if I have a difference of perfect squares. ACs are not hard, you just got to know. So far we've learned ABs, that's just a GCF, okay? Because you can always do a GCF with an AB, okay? Because it's x squared and x, you know you can at least do x. Then ABC, I see if I have a GCF, then I do that little table and then analyze what I have for A. And then this is how you do AC, and that's kind of the final straw. Okay, so let's look up 5 and 125. Those are both in the 5th row. Okay, 125 is clear at the end. So 5, now is it going to have an x with it? No, because C doesn't have an x. Is A negative? Yep, so that's going to be negative. So we actually are going to do the GCF. So we factor out negative 5, then I divide each of these by negative 5. So that becomes 1. It's an implied 1 with x to the second. And then minus 25. Okay, dots, you're in here now. Okay, now that you have the GCF out, you don't go to the original, you go in here. It's your new AC. Okay, if your A has a 1, that can be discarded. It has to be a 1, but it can be discarded. We can just forget about it. The minus is there, so 25 can be written as 5 times 5. X squared is x times x, so it's xx, 5. By the way, I forgot something. That negative 5 I should have placed right here, because that's going to go next to the parentheses. X plus 5, x minus 5. Okay, 36x to the second minus 121. So we have A, we have B. Or A and C. Dang it, that's a C. B ain't here, okay? Sorry, it's late. Okay, so ACs, I go GCF. See if I can do anything with that. And then I see if I have I can do the difference of perfect squares. Now I know the chart maybe is not going to show up because you don't have a 36th row. Okay. First, take your 121, see if you can divide it by 36. No, you can't. Now go find from the bottom up the first row with 36. Start at the bottom of your chart, so it's in the 18th row. Is 121 in the 18th row? Nope. Okay, 36 then appears in the 12th row. Can you divide 121 by 12? Nope. Okay, then it would appear in the 9th row. Nope. Then it would appear in the 6th row. Nope. Then 36 would next appear in the 4th row. Nope. Then it appears in the 2nd row. Nope. Then that just takes me to 1. So the GCF's 1. Okay. That's how you'd figure it out if your chart runs out. Okay. Okay, you have a minus. Now let's talk about 121. Is that on the list? Sure is. That's 11 times 11. Okay, about 36. Yep, 6 times 6. And is your x to the second power? Yep. If it was just x, it wouldn't. This would be prime, but it's x second. So I put 6x, 6x, then 11 and 11. So we have 6x plus 11 times 6x minus 11. Okay, final problem's an easy one. X to the second minus 1. I put the implied 1. I have an A and a C. B's missing. So with AC's, we see if we have a GCF over here. Okay. And then we see if we can do a difference of perfect squares. That's the game plan. Okay. Okay, so GCF 1 and 1 would just be 1. Can't do X, and it wouldn't be a negative because A is a positive. Okay, so we're not doing the GCF. I'll put check every time I don't do the GCF. So dots, make sure you got minus. 1 would be 1 times 1. 1 here would be 1 times 1. And then, by the way, why don't you just drop the implied 1 on your A? If you want to dots with A, if your A is an implied 1, just drop it, because that's X times X. So it'll be X, X, and then 1, 1. GCF wasn't done, so it's X plus 1 times X minus 1. If you FOIL that, it'd be X squared negative 1X positive 1X cancel, and then negative 1. X squared minus 1.